What we're going to take a look today is the slope of a line. In particular, we're also going to take a look at parallel and perpendicular lines, and here are some of the objectives for today's lesson. We're going to find the slope of a line given 2 points. We're going to find the slope of a line given the equation of the line, and we're going to determine whether two lines are parallel, perpendicular, or neither. And we're going to solve some applications involving slope. So what we have here is finding slopes from 2 points. We define the slope m of a line going through the points x1 and y1 and x2 and y2, shown here, where x1 does not equal x2. And this is given by the following equation. Here we have the slope m, we have y2 minus y1, which is just the difference of the y coordinates between these 2 points. We have x2 minus x1, which is just the difference between the x coordinates between these 2 points. Here we have a line with a particular slope, and how we define our slope is the rise over the run, where we have here x1 and y1 and x2 and y2. We define the run as the difference between x2 and x1 coordinates between these 2 points, and the rise is just the difference between the coordinates y2 and y1 between these 2 points. That's known as the rise. Another way to view the slope m of the line is that it's the change of y over the change of x. So what we have for the slope m is also notated here as delta y, which means the change of y in the numerator, over the change of x found in the denominator. And this triangle notation or icon is to denote change. So here in this case, it's y2 minus y1 is the same thing as delta y. Delta x is just x2 minus x1, which again means the change of x in the denominator. In the numerator is the change in delta y, or change of y. So here are some examples of slope, which is basically a measure of steepness. The one dealing with skiing, here's an icon showing that there's a steep downward grade up ahead. Here's one, I think, near some Aztec ruins. Someone doing some hill climbing, kayaking, and just a diagram of a measure of steepness or slope in this case. Now for some examples. Finding the slope of 2 points. Let's say we're given 2 points, -6 and 0, shown here, and 3 and 3, shown here. Draw a line between these 2 points, and let's find the slope for this. So we note that x1 and y1 corresponds to -6 and 0. Likewise, x2 and y2 corresponds to 3, 3. Using the equation of a slope, the change in y, which is the rise, over the change in x, which is the run, we have the following. We have y2 is equal to 3 minus y1, which is equal to 0. So 3 minus 0 is what's found in the numerator of m. Likewise, in the denominator, we have 3 corresponding to x2, and x1 corresponds to -6. So 3 minus -6 is what we have in the denominator. So our net result is 3/9 or 1/3. So this slope has a slope of 1/3, and we also note that it's a positive slope. So here, let's look at another example finding the slope between 2 points. Here we're given a point -2 and 3. That's located right here. We're given a point 3 and -4. That's shown right here. and we draw a line between these 2 points. Now we define x1 and y1 set of coordinate or ordered pair as -2 and 3, x2 and y2 defined as 3 and -4. Applying our definition of slope, which is the change in y over the change of x, y2 minus y1 over x2 minus x1. Using the definitions we described earlier, we have then on the numerator -4 minus 3, and in the denominator positive 3 divided by -2. That yields an answer of -7/5, and you can see here that this is a negative slope. One way to think about it is that if we go 5 units, let's say from here starting at 0 for the x coordinate and 5, then we go 7 units down, and that's how we describe the slope shown here.